Okay, so here is the first video for lesson 2A, properties of numbers. So most of this should be a review of things you went over in middle school or even in grade school. So the first two properties are the commutative property and the associative property. And they basically give us permission to rewrite addition and multiplication problems in different orders than what are normally given. So these properties are typically referred to as the commutative property of addition or the commutative property of multiplication, and the associative property of addition and the associative property, of multiplication. So it says, rewrite each of the following expressions using commutative and associative. You do not need to simplify the answers. So that just means you don't actually have to put anything in the calculator. All right, so for commutative, remember commutative simply means different order. So there are a couple things that I could do here. For 10 plus the quantity 5 plus 11. An example of commutative would be to, inside the parentheses, switch the 5 and the 11. So 11 plus 5. That would be commutative. The associative would be to actually move the parentheses. We keep the same order, 10, 5, 11, but move the parentheses. So maybe something like 10 plus 5 in parentheses plus 11. Okay. And even though order of operations tells us to do parentheses first, because we're only dealing with addition, it doesn't matter where the parentheses are. Okay. Now for the next example, 7 plus A plus B, this time for commutative, I'm actually going to switch the entire sum in the parentheses with the B. So B plus 7 plus A. Okay, that would also be commutative. As far as associative, I would go back to the original and leave it in order, but simply move the parentheses. Okay. Even though subtraction is not commutative, we should remember a very important fact about subtraction. It can always be made into the addition of opposites. Okay. Now, you don't have to do this when you're solving a problem. Some people prefer not to. Again, you're going to have your calculators, but this can sometimes help, especially if you have a hard time adding and subtracting negatives, if you don't have a calculator. So all this is saying is that this first expression, 6 minus 10 plus 3, we can rewrite that as 6 plus negative 10 plus 3. Now, how does that help us? Let's pretend we don't have a calculator. It helps us because if you think of a number line, we're starting at 6 and now we're adding negative 10. So we're going to the left 10. So if we do that, we would get negative 4. And then negative 4 up 3 or plus 3 would be negative 1. Now, would you get the same answer without having changed that to a negative? Absolutely. For the second one, negative 5 minus negative 2 minus 1. Well, again, we can change the minus to a plus, and the negative 2 also becomes positive. I'm not going to write that second plus, though, like that. So even though typically we deal with number lines horizontally, oftentimes with negatives and positives, you'll hear me refer to up and down, almost like a temperature scale. We're down at negative 5 and we go up 2. So we're at negative 3. And then we go down another 1. So we end up at negative 4. Okay. And finally, for the third one, we're only changing numbers that are actually being subtracted. That 7 is just a negative 7. So we're going to leave that. And again, I'm going to change the minus to a plus and then negative 2. So we're at negative 7 up 9. That would be positive 2. And a positive 2 and a negative 2 will always make 0. Okay. we can do the same type of thing even when we have variables. So here we have a little bit of, a review, a review of like terms. When you add or subtract variables, remember you can only add or subtract like terms. That means you have the same exact variable, and those variables, or that variable, has the same exponent on it. So for example, x and x squared cannot be added or subtracted. They're not like terms. And all you have to do is add or subtract the numbers in front. So for 3a here, 5x plus 2x, all we're doing is adding 5 plus 2 and then sticking the x back on. Okay. For b, we already have plus negative. So we have 7x plus a negative 3x. Well, we're up at 7, we're adding, or we're going down 3, so we end up at 4x. And now for C, we have negative 8x plus negative 2x. These problems I like the best because you're adding two negatives. That's the same as adding two positives. You just happen to be in the negatives. An 8 and a 2 make 10. This just happens to be negative 10x. Okay. But again, guys, you're always going to have your calculator. So, for part B, if you did 7 plus negative 3, that would be fine. What you want to be careful of is if you look at B, the way I had to type it, it looks like 7x plus minus 3x. If I try to put that in my calculator, it'll give me an error. Okay. So if you look at how I didn't write it here. If I were to write this and not have typed it, I would have written it like this, plus negative 3x. Okay. All right. And then our last property to go over, again, a kind of popular one, is the distributive property. And this involves addition or subtraction and multiplication. And we can also, again, use variables. So it says express the following products as binomial expressions. So throwing a little terminology in here, a binomial, think of the prefix bi, that means two. So our final answer should have two terms, not one. All right, so for number 4, 5 times 2x plus 3. Now, you can certainly write this out a number of ways. Sometimes when you're first learning the distributive property, you might see it written like this. Okay, and that's just to reinforce that you're multiplying both the 2x and the 3 by 5. So 5 times 2x is 10x. 5 times 3 is 15. They are not like terms, so we cannot add them together. And that's totally fine. Usually what we end up getting in the habit of doing, however, is not writing it out like that, just kind of going to the answer. So I'll tend to use arrows. So we're doing negative 4 times 5x. Well, that would be negative 20x. And then negative 4 times negative 8 would be positive 32. Okay. For C, x times x. Now, we're a little ahead of ourselves here. When you multiply variables that are the same, you add the exponents. Each of those x's has a little 1 on them. So when we multiply x times x, we get x squared. Then we do x times 4, 4x. Please remember that when you write the product of a number and a variable, to always put the number first. We don't write this. While using the dot is technically fine, you really want to get in the habit of not doing that. Okay? We want to write it as a single term with the number in front. And then for D, and remember, whenever I'm going over these problems, you can always pause the video and try them yourself and then come back to see, if you have them right. So 5x times 2 would be 10x, and 5x times negative 7x would be minus 35x squared. Okay. And the last thing to go over here has to do with division, but also the distributive property. Whenever you have a fraction where in the numerator, at the top of the fraction, you have addition and subtraction, if you're dividing by a single term, in this case, a number, you can basically use the distributive property. So for A, having 8x plus 4 over 2 is really the same as 8x over 2 plus 4 over 2. We can like split them up. Now, another way to think of this is when you divide by 2, what are you really multiplying by? 1/2. So we are multiplying 1/2 times 8x plus 4. And then you could use the distributive property that way. Either way, 8x divided by 2 would be 4x. Again, I'm just completing the arithmetic with the coefficients. 8 divided by 2. And then 4 divided by 2 is 2. So for B, again, I'm going to split them up. I mean, technically, especially as we move on, you might not find yourself writing it down that you're splitting them up. You might just do the calculation. So 25x divided by 5 is 5x. 50 and minus 50 divided by 5 is 10. Okay. Now, C and D are a good example of why you would want to split them up. And I'm actually not going to get too into this right now. But we would have 2x over 4 minus 16 over 4. Now, one thing that you're going to realize as we move on is you really shouldn't be writing decimals and fractions mixed together. It's not wrong. But if you're doing a multiple choice, especially, that's not how you're going to see your answer. So you really want to get in the habit of reducing your fractions if it doesn't divide. Now, 2 over 4 should be a pretty straightforward one. That's 1/2. I have a couple ways that I can write that. I can write 1/2 x like that. Or I could write 1x over 2. But whenever your leading coefficient or when your coefficient is 1, we typically don't write it. So I would probably just write x over 2. And then 16 divided by 4 is 4. Okay. So again, here we're going to split them up. Now in this case, neither one is a clean division. You know, we're going to have something left over, or we're going to have a fraction. That's again where your fraction button comes in. So if you feel a little iffy about reducing fractions, use your fraction button. So remember, that's alpha y equals number 1. So if I do negative 9 over 12, I get negative 3/4. And again, I can write it as the way I did here, negative 3/4 x or negative 3x over 4. It's the same thing. And then if I want to reduce 18 over 12, I get 3/2. Of course, it's important for you to be able to reduce on your own, but you do have the calculator there. You might as well use it to check things. Okay, so this is the end of lesson 2A.